Okay, now that we've looked at logarithms, we're going to look at something else, which is series, right? Series. Very important. It's a very important topic, and we're actually going to encounter these a lot, especially when we start doing our algorithm analysis. So it's good to get them out of the way right now. Well, not out of the way. It's good to understand them, right? And it's a very fascinating topic. Firstly, we've done series, right? Well, we have series that like n is equal to, let's say, I being equal to 0 of 2 to the power I is equal to 2 to the power n plus 1 minus 1. We've done things like this, right? But then we're going to be looking at a geometric series, right? So in a situation where we have n, right, n, and then we have I being equal to 0, right, of a to the power I, is then going to equal a to the power n plus 1 minus 1 over a minus I. And then in a situation where n approaches infinity, right, n approaches infinity, and 0 is less than a, which is less than 1, right? So if we have this less than 1 but also greater than 0, then our formula tends to be n, then this is 1, I being equal to 0, right? I mean, like, of a to the power I. Just a moment. Of a to the power I is usually less than or equal to 1 over 1 minus a. This is something that's very important to remember. This right here is very important to remember. In fact, most of the rules that I'm going to show you are very important to understand and remember, because you're going to be applying them a lot, and usually these are like some free marks in the exam, so getting them out of the way is very important. So we have this over here. I'm just flipping my book because I can't be bothered to remember all this stuff. Now I'm going to lay down a very simple geometry, a very simple series, right? A very simple series, and then the pattern I'm about to show you is one you're going to be applying a lot. So this one as well, remember it. So if we have our series S being equal to 1 plus a to the power 1 plus a to the power 2, and then this 1 is basically just a to the power 0, which is just 1 anyway, plus a to the power 3 plus dot 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 dot, right? What we can do here, right, to try and solve this one, try and put this in a situation where we can solve it, and basically I'm just extracting this formula. Is given this item, what I'm going to do is that I'm going to multiply this by a. So I'm going to have a s being equal to a plus a squared plus a to the power 3, right, plus keeps on going to infinity, right? We have an infinite number of terms. Since we have an infinite number of terms, we can say as minus, I can just say s minus a s, right? S minus as. What happens is that now each of these terms will pair together, and then they will subtract infinitely. Meaning what ends up happening is that these go the way they are, again to infinity, leaving us only with a 1. Since we have a 1 there, what we can do is that we can have s, then 1 minus a being equal to 1 there. So s is equal to 1 over 1 minus a, which is basically the formula that I just showed you guys, right? Again, this is something that will be very useful. This will come in handy a lot. So remember this. Just this pattern alone will get you out of a lot of trouble going forward, right? Now, a demonstration of this, right? A demonstration of this formula is a very simple question. Given that we have a summation to infinity starting at I is equal to 0, right, of the form I over 2 to the power I, right? Then I'm told to evaluate this, find the answer, right? You're just told to find the answer to this one. Fill up pen. I'll just be honest with you, because one, you can't just plug it into, let's say if I try listing out these terms, right? If I try listing out these terms, I'm going to have 1 over, first of all I'm going to have 0, right? I'm going to have 0 followed by 1 over 2 plus 2 over 2 squared plus 3 over 3 over 2 to the power 3 plus 4 over 2 to the power 4 plus dot 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 dot, right? It goes like that. Now most series, there was a thing that we did where we find the R. R is basically A in this case, right? This is basically R. You find the common divisor and then just come and plug it there. But in this case, we can't easily find that common one because what's common here, right? There's nothing that's making this common. So this is why we do a bit of witchcraft, right? To make sure that we put this in a form that this formula will accept. So basically going to change this equation, right? We're going to change this equation to something that is equivalent to it without changing its answer. So it won't look like this, but it will still give us the same answer, right? So how do we do this? Well, again, I told you, remember this pattern, very useful pattern. So we're going to say S is equal to 1 over 2 plus 2 over 2 squared plus 3 over 2 to the power 3 plus 4 over 2 to the power 4. Okay, now that I have this, what do? We multiply it by the denominator, right? I usually multiply this by the denominator and it gets the job done. So we're going to have 2s being equal to, so this is going to be 1 plus 2 over 2 plus 3 over 2 squared plus 4 over 2 cubed plus continues to infinity, right? Continues to infinity like that. So you don't have to care about the other terms, just assume that the other terms keep on going like this. So now what do? We subtract these two together, right? We subtract these two. So I'm going to say 2s minus s, right? It's going to be 1 minus the 0 that's here. Remember there's a 0 here. 1 minus 0, that gives us the 1. Then we pair those that have similar denominators. This is going to be 2 over 2 minus 1 over 2, right? 2 over 2 minus 1 over 2 there. This is just going to give us 1 over 2. We continue. 3 over 2 squared minus 2 over 2 squared. This is going to be 1 over 2 squared. 4 minus 3, that's going to give us 1 over 2 to the power 3. Plus, it keeps on going like that to infinity. Right? Just be 1 over 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, all the way up to infinity. Right? It definitely keeps on going like this, and this is s. So what have we done here? We've basically gotten this equation and transformed it to a more digestible form. Right, now this digestible form, we can find a common divisor here. This is 1 over 2, right? We multiply this by 1 over 2 to get this, multiply it by 1 over 2 to get this, multiply it by 1 over 2 to get this. So basically we've seen that, okay, we're multiplying each term, right, by 1 over 2 to get the next one, which is why we usually have that form of 8 to the power n is equal to r 8 to the power n minus 1, right? So the next term is equal to the current term times r, which is what we basically have here. And then this r is the one that we use in that formula, or in the way I wrote it for you, we wrote it as a. So you can basically say s is equal to 1 over 1 minus a, which is 1 over 1 minus, here is 1 over 2, which is going to be 1 over 1 over 2, which is just going to be 2. And that's the answer to this equation. This is 2. And yeah, just like that, you've solved this summation, and that's how you go about with most of these summations. So now that we have this covered, I'm then just going to show you 3 more formulas that are going to be very useful, and then we do a few more questions. And after I do those questions, yeah, we'll be done with this topic. Yeah.